So here we are with our no frills box, and we want to do the cam on it now. So we've done this, I've done this several times and can't get the parts to fit together nicely, and trying to figure out why. One reason may be that I'm using 2D adaptive for the pockets. Really, I guess it only matters if it's the pocket on the bottom, because the side to side fits, but the trouble seems to be at the corners. And I use 2D adaptive because why not? It's a fancy one. So let's use 2D pocket instead. It kind of makes sense because, as you'll see, the toolpath for 2D pocket intuitively looks like it might make the fillets a little more accurate. I don't know. Bottom line, let's do the cam on this one. So here it is. So we're already on the cam tab. So if you're not already there, click there. First thing we want to do is set up, and then we hit tool isometric, and then on this side at least it's easy to put the part reference 0 here, and so that's good. And then the stock, I just say fixed box size because I'm going to take off that 1/8 of an inch around the perimeter as we've talked about, so I see no reason not to take that particular choice. So there's our setup. Let's first do the contour, which is going to reduce the perimeter of the box by 1/8 of an inch, and that would be a 2D contour. The tool I'm going to use, I've already been playing around with this a little bit. One of these days we'll get a PLTW library here. We're not there yet, so what you'll want to do is put a half in here and then go looking through here and make sure you'll get a flat end mill. You can do it by type, or if you do it by material, down here to, let's see, aluminum, it'll pop up as well. Let's see, let me cancel there and go back here. Yeah, you'll find it. So it's a 1/2 inch. It's got 92 for the feed rate, so yeah, pick that one. Okay, so there is our tool, and then for the geometry, for the contour, we're going to pick the perimeter of the bottom of the contour, and then come to heights, and the top height is the top of the stock, which is what we want, and then for the bottom height, we'll change this to the selection, and then we'll come over here and we'll pick that area, because that's the bottom height. And then for the passes, I'm going to leave everything the default except for multiple depths, and change that to half the diameter of the end mill, which is 1/4 inch. And otherwise, I'm going to leave everything the same, or the default values. So if we simulate here, we can convince ourselves that everything looks good. Should do it 4 times because we want to go down a full inch, and we're at 1/4 inch step down, so that looks good. Next thing we want to do is the second contour, which defines the lip here. So let's do 2D contour again, and the tool is still here, and we're going to grab the contour right there. And for the depth, we're going to do just what we did before, selection. And then I have found that in order to grab this area, I got to be kind of close up to it, or it won't grab. Okay, here, just for multiple depths, just for good practice, I'm going to go multiple depths of 1/4 inch like I did before, but I know this is already 1/4 inch in size, so I know it's not going to need more than one, but just for good practice, I'm going to choose multiple depths. Let's simulate just that part. Okay, that looks pretty good. Now let's do the middle part here. I've been using 2D adaptive, and for various offsets that have historically worked in the past, albeit I believe it was overwhelming evidences with Mastercam and different CAM software, I have had trouble getting the thing to fit together. So using 2D adaptive, which is the fancy one that is optimized to avoid abrupt tool direction changes. But I'm going to use 2D pocket this time. So the tool is still our 1/2 inch end mill. We can select the geometry here, like so. For the depths, the selected contour for the pocket, don't need to change that. And then for step downs, let's see, no stock to leave and multiple depths, 0.25 again. And I think we'll use the defaults for everything else, and let's see what that looks like. So this should come in a helical fashion, and then it starts to go in and move around parallel to the length of the sides, parallel to the sides of the boxes, which hopefully makes these fillets more accurate rather than the 2D adaptive, which does some circles and then goes and grinds out the corners after the fact. I don't know, I'm just guessing there. So let's do the whole business here. First, let's name this bottom and simulate the whole thing. And let's see, I think that should do it all the way. Yeah, there we go. So there it goes around there. It'll go down 4 passes of a 1/4 inch each to get a a full inch all the way down. And now it does the lip, and then it does the interior with the 2D pocket. Right now I've got 0.005 as my offset. We'll see if that works. Alright, so there it is. Alright, let's do the top. So we turn it over on its back, like that. And we can come up here and do another setup. And let me get this in a slightly better isometric-y. Whoa, no, don't do that. Uh-oh, this is going to get me in trouble. Let's do that again, shall we? So let's click right there. Okay, those directions aren't what we want. We want that direction is fine. So we need to reverse basically Y and Z. Sorry, Z and Y. Yeah, same thing. Okay, so let's try this. So I can flip Z there, and it worked. Okay, so you might have to play around with that a little bit. For this one, if X is in the other direction, you can click on a direction parallel to the X direction that you want, and it'll work. So I think that's okay. That's exactly what we want. And then for the stock, I'm going to again use fixed box size. Okay. And now let's do what we did before. Let's do the 2D contour. The tool is still the same, and contour selection is down there. And then in terms of the depth, I'm going to change this to selection and grab that. And my step downs are going to be 1/4 inch. Defaults for everything else. And oh yeah, I can hit tool isometric, by the way, now that I've changed the part reference 0, or the location of the origin. And I can simulate here. And this goes down 1/2 inch, so it should have 2 passes. And there we go. And now what we need to do is do the interior here. By the way, this is the pocket, of course, that is going to matter in terms of the fit. Okay, tool isometric. Uh-oh, what happened? What happened? Let's go to this setup. Tool isometric. There we go. So I was on the other setup. Okay, so this is the 2D pocket that's going to impact the fit, because this is the area that fits over the lip. So 2D pocket. Tool is still our 1/2 inch end mill. Can click there. Don't have to change anything there. And again, no stock to leave here, and I'm going to use multiple depths of 1/4 inch, 0.25. Okay. And I'm just going to, first of all, change this to top, and then simulate the whole thing from the top. Okay, so yeah, that went down 1/4 inch, and I believe that is, where are we at? That's what it should be. Yeah. Okay, so that should be the cam for this particular part, and we can see if it fits after we mill it on the CNC machine.